For stars greater than 2 solar masses, it's a little bit different. No helium flash. And that's because the mass is sufficient to compress and heat the core more smoothly until it reaches fusion temp. There is no degenerate material created in the core. And the safety valve, if you want to call it that, is maintained by a kind of a 5-step process. One, cooling results in compression. Two, compression results in more fusion. Three, fusion gives us more expansion. Four, expansion gives us cooling. 5, repeat. So yeah, at this point, the star is almost breathing in a way, okay? And that's going to get us to something very important here in just a little bit. But that's what's going on. It expands. If it expands, then it cools. If it cools, then it shrinks. If it shrinks, it compresses. If it compresses, more heat. More heat is more fusion. More fusion means it expands. And this process is going on at this point. This gets us to the triple alpha process. This is really important. This is why we exist. Okay, I'm going to get into the weeds with this one, but it's important that you know this. Number one, 3 helium atoms form a fuse to become carbon atoms. Okay, so how does this work? Well, one of the ways that we indicate elements is like this. Here's how I indicate helium, and see that 4 there? That 4 indicates that there are 4 pieces and parts in the nucleus of a helium atom, and there are 2 protons, 2 neutrons, okay? So, two protons, 2 neutrons. Also, you should know that helium atoms, at least in astronomy land, are also referred to as alpha particles. Helium nuclei, rather. Helium nuclei are called alpha particles. All right. Okay, so here's the process. And believe it or don't, this is actually kind of the stripped down version, but here's how it goes. Two helium nuclei fuse to become beryllium. Okay, beryllium has an atomic number of 4, which is to say 4 protons in the nucleus. So that would be 4 protons and 4 neutrons. So we would write it like so. Okay. 10 to the negative 8 seconds later, that is 10 billionths of a second later, a third helium nucleus collides with beryllium. To become carbon. Right. So a way that you could indicate that would be like this. Okay. Helium plus helium plus helium, 4, 4, 4, yields carbon, 12 nucleons, 12 particles in the nucleus, plus this. In this case, a photon. So this fusion process releases photons. This is where the energy from fusion comes from. Or, so when we talk about fusion releasing a lot of energy, that's where that energy is released in the form of that photon right there. Also what happens in this process is carbon plus helium collide and forms oxygen. So we would indicate that as like so, 12C plus 4He yields 16O plus a photon. Okay, now this gamma, Greek letter gamma in this case, is energy Okay, so Greek letter gamma in this context refers to the energy released as gamma and X-rays. Remember, high frequency equals high energy. Okay. That's the triple alpha process. So here we are, these carbon-based organisms sucking down oxygen and exhaling carbon dioxide. Where did those oxygen molecules and carbon molecules come from? They came from the interior of a star. So that's what you're inhaling and exhaling all day long, is stuff from the interior of a star. That's where carbon and oxygen come from, the fusion process inside a star. All right. We'll pause here.